Hey guys, so I'm Warren, as you probably already know. Today we're going to be talking about real heat engines, but before we do, you really need to know force equals work times distance. So basically all of these engines take advantage of that. Basically, if you exert a force on something over a distance, you put work into it, that might be released as thermal energy, it might be in potential energy, and then as you can hear, it has energy, so it's So, the first thing we're going to be looking at today is the combustion engine. So basically what the cycle of a gasoline combustion engine looks like is you have your compressed engine, it expands, so this is turning the entire time because that's what the engine does, that's what it's designed to do. So this is turning, which makes the piston draw in the fuel. So this is filled with air and gas. Then it compresses, so it's at a really high pressure, and then ignites it with a spark plug, which causes the explosion to press the piston out. And this is the force times distance part. It harnesses this energy to keep the engine turning and to turn whatever else is hooked up to it, i.e. your wheels. So let's take a look at how this looks in cycle. So as you can see, all these pistons are on different parts of the cycle. That's because in order for this to compress to push out the gas and to draw in the air, the entire engine has to be turning to draw the turning of the piston. So again, let's take a look at this graphically. So first, you have your exhaust and your gas-air mixture is drawn in. Then it's compressed by the turning of the engine, and then the spark plug ignites it, and it explodes, so pressure shoots way up. But then as it presses the piston out, and we harness the energy, the pressure goes back down as the piston chamber expands, and then because of the turning of the engine, the exhaust is expelled, and the air-fuel mixture is drawn back in again. And we can repeat the cycle. Really similar to the gasoline engine is the diesel engine, which basically only differs because it doesn't have a spark plug, so it just uses the pressure to ignite the engine. So again, you have your only air mixture. This time it's not air-fuel. It's compressed by the turning of the engine, and then as the piston reaches the height of its compression cycle, the fuel is injected, which then immediately ignites because of the high pressure, and then it expands the piston, so we can harness all this work. And then as it turns, it expels the exhaust and draws in new air, and we can do it all over again. So the last kind of engine that we're going to be looking at is the steam engine, which is a little bit more complicated, but not much. So basically, we need a heat. So in the gas and the diesel engines, the heat reservoir is not really a heat reservoir, it's the chemical energy in the fuel, the diesel or the gas. And the cold reservoir is the air. In this one, we actually need a real heat reservoir and a real cold reservoir. So the cold reservoir is usually the ocean or some body of water. The heat reservoir is some water that's been heated because of either burning fossil fuels or there's lots of ways to do it. The most common are fossil fuels and nuclear fission. So let's start here. We have cold and uncondensed water. We put it into a pump, its pressure goes up, we put it into a boiler, that makes it superheated, which means that if not for the pressure holding it together, it would evaporate. Then we let it into the turbine chamber where it expands, becomes steam, and that expansion pushes the turbine, that's the force times distance part, and that's why we can gather work from the turbine. And then since we need to cool down the turbine chamber so that we can do it again. We put it into a condenser where it's exposed to cold water, and then you can repeat the cycle. So again, starting from here, you pump the water, the cold water, it's really pressurized. You let it into a boiler, it wants to turn into steam so that when you let it out into a place that's not as pressurized, like in the turbine chamber, it expands really fast, but loses pressure as the turbine turns. And also because it's just in more space, so it's not as pressurized. Then you put it into a condenser so that you can repeat the cycle, so that heat will actually like have the effect of making the water expand and contract. Next, we're going to take a look at how you can calculate the efficiencies of these different cycles.